In this video we will talk about preparation of your VPVision project. Good preparation is really key to success and to minimum amount of time spent on site when installing VPVision. So let me take you through the highlights of a well-prepared VPVision project. First of all, it starts a lot of times with a visit to the plant, making pictures of the existing equipment and existing pipework, making decisions on where to put the sensors in the pipework and on the machines, and combine that with the P&ID, which might be in most cases already there, but it might need some updates because sometimes people tend to add things to the compressed air system without updating the P&ID. You also want to have a plant map of basically an overview of the plant, of the rooms, the compressed air room, the production hall, so you know in the end the distances between the sensors, the measurement points, the I/O modules and the VPVision main cabinet. Proper documentation is really key when preparing the VPVision project. And we provide you some tools for it. You can download from our website the Excel sheet, which can be used to create a list of all the equipment which you're going to use, the IP addresses, the sensors, the I/O modules, everything in one convenient list, so you know what will be installed. The second thing you want to do is create an overview of the complete system architecture with all the parts interconnected. So the sensors, the I/O modules and the VPVision M in one clear system architecture drawing. In the next chapters we'll take you further into detail into each step. On your site visit, when preparing the project, it's important to look at the location of all equipment. For example, the VPVision main unit should be in a place where the environmental temperature does not exceed the maximum temperature. Then looking at the sensors, you have to check on where they are located and if you might need a scaffolding or ladder or scissors lift to access them. Another thing which is important is cabling, and in some countries conduit pipe, to shield off the cables from any external RF interference. So in that case you also need to pay close attention to how that will be installed. Also important with that step is to check if there's mains available to power up those remote I/O modules and the VPVision main cabinet, because you might need a contractor to make additional mains outlets to power that equipment. Again, preparation is key, so keep your eye on all details and make notes, make pictures to make sure that you're well prepared for the next steps. As mentioned before, the P&ID is very important. It will contain all information about the relation between the equipment and the sensors and how everything is interconnected together. What we often find is if you go to an older plant that the P&ID might be outdated. So that's why a site visit is so important, so you can make adjustments in the P&ID and get to the situation as is. In the P&ID, eventually you are going to add the measurement points. So when the project is ongoing, you can use the P&ID as a sort of central document to communicate with all the stakeholders, to show where the sensors are, to show where the equipment is installed, and also to show how the relation is between all those elements together. So now let's go over an example on how to prepare your project using a P&ID. Here you see a schematic of a generic compressed air installation with a high pressure network and a low pressure network. Of course, you can also use a real P&ID for this purpose. In this example, we will install power meters on each compressor. There will be several flow meters on both supply side and demand side, and there will be dual point sensors. All the sensors are already drawn here in this P&ID sketch. Next, it helps if you know where everything will be located. So this helps you to determine what will be the easiest way to connect your system. For example, are sensors located in different buildings? Or are they located far away from the central VPVision unit? Where is the network cabling? Can you connect it maybe to a nearby network interface from the company network? Now the final step is to determine per sensor how to connect it to your VPVision system. In this example, we have connected the power meters in the high pressure network directly to an RS-45 to Ethernet converter, which connects to the Ethernet. We have connected the flow scopes and the dew point sensor to a RS-45 daisy chain, which connects also to a separate Ethernet converter. And this converter connects to the company Ethernet. In the low pressure network, we connected all the flow meters together with the kW meters and connected them directly to the RS-45 input of the VPVision. The dew point sensor in this case is connected with the analog input of the VPVision. It's a third-party dew point sensor in this example. VPVision M is connected with the Ethernet interface to the company network, so it's able to find all the other sensors in the high pressure network compressor room. Looking at the demand side, we have 3 flow scope M's, and the flow scope M has a built-in Ethernet interface, so it's connected directly to Ethernet. So now you see that everything is tied together using the Ethernet of the company as the main infrastructure for exchange of data, and every data point is again stored in the VPVision M unit, which is located in this case in the low pressure compressor room. So now it's time to proceed with the next step. You need to think about junction boxes, so you need a junction box per Modbus device, and there could be limits for the number of Modbus devices based on power consumption and data traffic. Cable length and cable installation can have a huge impact. So if you have a large plant-wide monitoring system, you want to use as much as possible the Ethernet infrastructure which is available. So that's where the remote I/O modules come in place. For example, the 4-to-20 to Ethernet converter or an RS-45 to Ethernet converter. And also don't forget about sensors with a direct Ethernet output on the sensor itself. For example, the flow scope M can be connected anywhere in the plant on the Ethernet system, Ethernet network, and you can centrally read it out through VPVision. And that also is applicable to some power meters which are available for the VPVision system. Final step is the wiring diagram. Now you know every I/O module and where it should come, then you can start to make detailed wiring diagrams of all the interconnections. For example, for an analog I/O module, you want to be clear on which sensor is going to which channel, and you want to document that, because you need that documentation later when configuring VPVision. When it comes down to Modbus, it's important to work consistently and use always the same colors for A and B, plus 24 volts and 0 volts. So there's not any confusion somewhere or any wires is mixed up, because it might damage sensors or it might cause the whole Modbus chain not to work. Finally, the Ethernet connections should be also well indicated on those wire schematics. And it's good practice to enter also the IP addresses on each document where there is an IP Ethernet converter involved. So now you're finally completely prepared to get started. So let's get on into the factory and install the equipment.